Okay, page 543, number 10. A batter hits a baseball giving an initial velocity of 41 meters per second at an angle, so VI 41 meters per second at an angle of 47 degrees above the horizontal. It's a home run, and the ball is caught by a fan in the stand. So it goes up, it comes down. Here are the bleachers. Somebody catches it here. And it says the vertical component of the velocity of the ball when the fan has caught it. So the VFY is 11 meters per second down. Okay, and it wants to know how high is the fan above the seats. You're looking for the delta dy. So you can find your VIY. You know your AY. You know your VFY. Can't you find your delta D, right? VFY squared is equal to VIY squared plus 2AY delta dy. And you're looking for delta dy. So delta dy is going to be equal to VIY squared. So VIY is VI sine theta, and that's going to be squared. Except really that's not what I wanted. I need to rearrange. This is VFY first. Do that. So this is VFY squared minus VIY, so VI sine theta squared, and then divide it by 2AY. So delta dy is equal to negative 11 meters per second squared minus brackets 41 meters per second sine of 47, close the bracket, squared, divided by 2 times negative 9.81 meters per second squared. And when you do this, you should get a delta dy of 39.66 meters. It works out to be positive because it ends up higher up than it started. That's number 10. Number 11 says, during a baseball practice, you go up into the bleachers to retrieve a ball. You throw the ball back into the playing field at an angle of 42 degrees above the ground. So you're higher up and you're throwing it down. So this angle is 42 degrees, and it's going to go up and come down like this. Giving it an initial velocity of 15 meters per second. So VI is 15 meters per second. If the ball is 5.3 meters above the level of the playing field when you throw it, what will be the velocity of the ball when it hits the ground? Okay, so you're looking for VF. So to find VF, you need VFX. VFX is equal to VIX, which is equal to VI cos theta. So 15 meters per second cos of 42. And when you do 15 meters per second cos of 42, you get 11.147 meters per second. And then VFY, you can do what we did over here. VFY squared is equal to VIY squared plus 2AY delta dy. So VFY squared is equal to brackets 15 meters per second sine of 42 squared plus 2 times negative 9.81 meters per second squared times negative 5.3 meters. Remember, that's going to be VFY squared. You're going to take the square root and hopefully get 14.308 meters per second. So in the x direction, 11.147 meters per second. In the y direction, going down of course, 14.308 meters per second. And so here will be your VF, square them, add them together, take the square root, and get 18.138 meters per second, and the angle is 52.08 degrees WRT with respect to the ground. Okay, so that finishes that one. I also asked you to do number 1 and 2 on this sheet. Number 1 is a double angle again. Okay, so a fire hose. Find the edge of my paper. So it's going to be doing this. Okay, so it says a fire hose shoots water, speed of 7.5. So VI, 7.5 meters per second. At what angle? Looking for theta. Angles will it need to be to land 2 meters away? So in the x direction, VIX is VI cos theta. AX is 0. Delta dx, 2 meters. In the y direction, VIY is VI sine theta. It's going up. AY is 9.81 meters per second squared, going down. Okay, we can look at just up, and we can do AY is equal to VFY minus VIY over delta t, and we can do the U, and we can get an expression for our delta t, negative VI sine theta over AY, but we can't find it. We have 2 unknowns here. So our time total would be negative 2 VI sine theta over AY. So then we come over here, because we have 2 unknowns, we need 2 equations. So VIX delta t, 1/2 AX delta t squared. This will go to 0. So we'll have delta dx is equal to VI cos theta delta t. Now we have 2 equations, 2 unknowns, sub this one in here. So delta dx is equal to VI cos theta, and then negative 2 VI sine theta over AY. Bring your negative AY over and divide by your VI squared, and you'll be left on this side with 2 sine theta cos theta, which is that double angle identity again. It becomes sine 2 theta. So sine 2 theta is equal to AY delta dx over VI squared. So negative 9.81 meters per second squared times 2 meters divided by 7.5 meters per second squared. Okay, and when you do this, if only I had the answers so that I don't have to waste a lot of time. Somewhere I do. When you do this, you get sine 2 theta to equal 0.3484. Take the inverse sine of both sides and get 2 theta to equal 20.39 degrees. So theta is equal to 10.21. I must have screwed up somewhere because that's not half. And then therefore the second theta would be equal to 79 point, maybe that's a 0.8. Okay, so there are my 2 thetas. The question asks, just for the 2 possible angles, we did it. Can I get number 2 done? A hunter aims directly at a target. The hint here is directly means horizontal. Same level, 140 meters away. Delta dx is 140 meters. And then it says the bullet leaves the gun, so they're telling you the VIX, 280 meters per second. How much does it miss the target by? Delta dy. So it's a horizontal projectile where the VIY is 0. So in the x direction, delta dx is equal to VIX delta t plus the stuff that goes to 0. You can find your time, delta dx over VIX, so 140 meters over 280, and you get a half a second. And then you use that in the y direction. Delta dy is equal to VIY, delta t 1/2 AY delta t squared. This goes to 0. Delta dy is equal to 1/2 9.81 meters per second squared times that, half a second squared. Most people, the issue with this one is they don't recognize it as an